Thanks very much, Ross, and thanks to all of you for turning up tonight. I hope you're having a good time so far, and I'll try not to delay your access to food and drink by too long. So I'm going to let you into a secret. I'm going to tell you what conservation is really about during this talk. I like to think in pictures, so the first thing I did when I wanted to understand what conservation was about was to go onto Google and do a Google image search. And I looked at the images that came up on these first few pages of the Google image search when I typed in the words conservation. And these pictures tell an interesting story. Almost the first person that comes up is Professor Paul Ehrlich from Stanford University in California. Here posing, no doubt, for a press picture with some of the famous scrub jays that he works on. The second picture was also from Stanford University. California dominates conservation science according to Google. That's a coincidence. A PhD student here, out in the field, getting excited about the species she's studying, getting down there with the plants, out there in the field, and loving it. She's passionate about what she's doing. A lab expedition. No doubt these guys are obviously diving, getting really passionate and up close and personal with the marine life that they study. These are the kinds of images that you see if you type conservation biology into Google. And of course there's fluffy things. There's a lot of fluffy things when you type conservation biology into Google. Now I'm a bird watcher, but I'm afraid birds just don't cut it when it comes to conservation biology. It's all about fluffy mammals. And more mammals, and yet more mammals. And of course the iconic mammal is not long before you get to a picture of a giant panda if you type conservation biology into Google. These are the first few pages. This is what the press focuses on. And of course deep down, even I love stuff like this, really. They're pretty exciting. They're really the flagships of conservation. And these kinds of things get us passionate, and they get the general public passionate about saving these things. They're flagships for our cause. No problem about that. But then I found some more cool stuff. Here's a collection of beetles. This begins to represent, the other 99.9% of biodiversity that's out there. This stuff that the world actually really depends on. Plants and invertebrates. There you go, John. I also found this one. I'm not quite sure where this came from. Maybe it's a self-portrait by some professor. It may even be me, actually. And as well as those species, another theme really came out of this search that I did. The theme was wilderness places. Pictures of conservation scientists out there with nature, with them and nature, and nothing else. Where are the threats to biodiversity in these places? Conservation biologists love biology. They want to get out there into the wilderness and study the plants and animals that they love. That's why I got into science in the first place. As a kid, I would poke around in my backyard, fiddle with ants, squash bees, and you name it, really getting in there with nature and experiencing it. Of course, that's why many of us are sitting right here in this room today. Other wilderness places, gorgeous landscapes where biodiversity reigns. These are the kinds of images that dominate conservation biology. An expedition out into the arid zone here, just loving getting out there with biodiversity. But of course, the threats to biodiversity are not quite so romantic. The places where biodiversity is being destroyed and replaced by the human endeavour, they're not really places where biologists want to go. That's not why we're here in this room today, because we love studying cities and farmland and all that stuff, but that's where the real threats to biodiversity happen. And it's understanding and trying to reverse those threats is what conservation is all about. It's about taking action out there in the real world and changing the course of history for the better. So we need to engage with these kinds of places and understand how to reduce our threats on the planet if we're to make real progress in conservation science. These kinds of images never came up in my Google search of conservation biology. And in a sense, why would they? It's not the kind of image that conservation biologists want to present. But these are the kinds of places we've got to study, we've got to get these threats worked out and understood. Large-scale agriculture dominates vast proportions of the earth. We need to understand how to do these things better so we can keep what's left of our planet in reasonably good condition. So reversing and understanding those threats is really what conservation is all about. And to do that, we need, as Bernd was saying, a whole bunch of different skills. It's not just about understanding how the world works, it's about trying to change how the world functions, or change our relationship with nature, try to improve it and enhance it. That's what conservation biology is all about. Maybe the word biology is not quite big enough. It's a much bigger thing than that. If we're going to make change in the world, we have to get out there, we have to talk to people, we have to convince people, and we have to show them that we're passionate about this stuff and we're interested in trying to change the world for the better. So conservation is about getting out there, and it's about doing stuff, and it's about making sure the actions we take out there in the real world actually will be effective, will improve ecosystems, can help restore them, and so on. This is what conservation is really about, taking action. Whether it's practical on-ground stuff, whether it's engaging in international discussions, or discussions at any kind of level, a local council trying to do a development or so on. There are ways that we can engage both individually and professionally as scientists. And this course will help equip you with the skills you need to engage with environmental problems right from a local scale, right through to a global scale. In 20 years' time, you could be at these big global meetings trying to direct the course of conservation in the future. This is where the action happens. Some of you might recognize this. This is a super trawler that was banned from fishing off southern Australia a few years ago. This raised an interesting thought in my mind about the kinds of questions we often ask as conservation biologists. We've written thousands of papers on how fishing depletes fish stocks. People have compared levels of fish abundance inside and outside protected areas and shown that if we reduce fishing activity, that increases fish populations. Now that's a piece of biology. It's not particularly surprising. If you catch fish and kill fish, there are fewer fish out there in the environment. That doesn't necessarily help us design marine reserves in a sensible way, to cope with the multiple demands of coastal ecosystems that Selena was just talking about. That's the kind of science we need. Not just the fundamental biology, but real-world action science that's focused on how do we save this thing, how do we get people on board, how do we spend money in a sensible way. And you'll receive a huge amount of stuff that's focused on these big questions of how we take action in a sensible way. And I'm just going to finish with a few examples of recent graduate students from this department right here at UQ and give you some very different examples of how their work has affected the world, hopefully for the better. Each person working makes the world just a little bit better. This is Sue Pillans. She did a PhD in Moreton Bay, really trying to understand the impacts of different kinds of protection on the biodiversity in Moreton Bay. Her work was taken up and used to help with the rezoning of Moreton Bay. So her PhD thesis was used to help make better decisions out there in the real world. And it was not without controversy. So there was a lot of media attention around this. It's tough engaging in that space. It's not a comfortable ivory tower thing. You're actually getting out and saying, hey guys, I want the world to be different. That's not just a scientific endeavor. Sue got out there and promoted and campaigned as well as doing the science. Secondly, we've been doing some work in cities, trying to understand how better to design cities. Now, I didn't get into biology because I love cities, but I recognize that cities are extremely damaging for biodiversity. How can we build them better to minimize the impact on nature? And asking this kind of question is a much more focused way of doing science. If we can speak to policymakers about, here we have some evidence that you should do this rather than this, you're focusing the question on a decision out there in the real world and not simply on an academic scientific exercise. So a master's graduate, an MPhil graduate from a few years ago, did some work on this exact question. How should we grow Brisbane in a way that least impacts biodiversity? These are real questions in conservation. They're applied scientific questions. Jessica showed that the number of extinctions that we would get from urban development were much lower if we build our cities in a compact manner. So we pack more people into a smaller area, and that minimises the impact on biodiversity. She actually took a couple of options that Brisbane City Council are considering and worked out which one would give the greater impact on biodiversity. So really policy relevant work that helps us design the world in a better way to minimise impacts on biodiversity. She published a great paper as a result of that work, so she's doing great science, but it's also having an important applied impact for policymakers. And she's now promoting that work. Finally, Nick Murray recently submitted his PhD thesis, last week in fact, here at UQ. A great example of the kind of work you can be doing here. Nick studied, using satellite data, coastal ecosystem loss across China and Korea. This is the coast of the Yellow Sea. China here, North Korea, South Korea. He mapped how much of that coastal habitat had been lost in 50 years and shown some terribly dramatic declines in coastal habitats in that part of the world caused by coastal development. And Nick has been working hard to campaign to improve decision-making around coastal zone development. And his work has been integrated into an IUCN action plan to try and improve that situation. So trying to use our work to help guide decisions in the real world. So conservation is all about changing the world. It's not about doing a piece of science. It's about using that to get out there and make a difference in the world. That's why you're all here, and that's where we want to see you equipped to do after you leave this course. Conservation is about money, it's about power, it's about politics, it's about media, psychology, social policy, philosophy, religion, and a little bit of biology. Thank you.